9FC, energy and reactions. Now, we might remember from 9FB that if we got together a metal and an acid, we end up with a salt and hydrogen. And if that metal is potassium, and if that acid is nitric acid, we end up with potassium nitrate and hydrogen. In this section, they start talking about how we can use potassium nitrate as an oxidizing agent. Oxidizing agents are very helpful for releasing oxygen when we have a reaction going on. Why do we want to release all this oxygen? Well, maybe because we want a bigger and faster reaction. We often make gunpowder out of potassium nitrate by adding it in with powdered charcoal. And as we know, gunpowder does a nice big explosion for us. To get a bit more specific about how this works, we have carbon in the charcoal, and when you're heating the potassium nitrate, this undergoes thermal decomposition, which is a phrase we've learned earlier. It gets heated and it breaks down and releases oxygen. That oxygen then joins up with the carbon in the powdered charcoal and makes carbon dioxide. And as a bonus point, as the carbon has gained oxygen, we can say this has oxidized. Okay, so explosions happen more quickly if we add oxidizing agents, but they also happen more quickly if we break the fuel that we're using down into teeny tiny pieces. The tinier the pieces, the more surface area there is available for that reaction to occur. There's also a picture on this first page. Now what's going on here? They want to remind you about how to test for the presence of oxygen. How do we know if oxygen is there? You can use a glowing splint, and if this happens, then oxygen is present. Next on this page, they remind us about the difference between exothermic and endothermic reactions. We've spoken about this a little bit before already, but we'll just do a quick recap. In an exothermic reaction, energy stored in the reactants is transferred outwards to the surroundings. In an endothermic reaction, energy is transferred inwards from the surroundings. Two examples of exothermic reactions are combustion and neutralization. And an example of an endothermic reaction is thermal decomposition, which we also know about, using heat to break things down. Some last things to note: lots of exothermic reactions need a bit of energy to start them off, like a flame or a spark to get them going. Some endothermic reactions, like thermal decomposition, need a continuous input of energy. So if we're trying to break things down with heat for thermal decomposition, we need that heat to keep heating our reactants up, to keep the reaction going. They talk about methane's exothermic reaction with oxygen, and they talk about how it needs a flame or a spark to get going. And once it gets going, the methane, which is made up of hydrogen and carbon, it's a hydrocarbon, keyword. The methane's hydrogen and carbon both separately link up with oxygens. So we end up with carbon dioxide, carbon and oxygen together, and hydrogen and oxide together, which is water. That's just one example of the way that we use a spark at the beginning to set off an exothermic reaction. And that's it for that one.